Okay, this is a video tutorial for 6.3, how to multiply fractions by fractions. The questions are from Mathlinks8, chapter 6.3. The first question we're doing is saying, Brendan calculated that 3/5 times 2/5, and he did this. He said 3/5 times 2/5 equals 6/5. What mistake did he make? Well, you have to know your algorithm or your way to get the answer. And in this case, what we've learned is that if you want to get the product of two fractions together, you simply multiply the numerators and multiply the denominators. In this case, you get 6/25. That's the answer that he should have got. That's the correct product. But what did he do wrong? He kind of used the idea of these two rules together. If you think about these two rules, if I was to do 3/5 plus 2/5, when you learned how to add fraction, you realize you have to keep your denominator and then add your numerators. So what Brendan did is he used the denominator rule for addition and the multiplication rule to get his numerator. Okay, so he's using two sets of rules to get the answer. He shouldn't have added he should have multiplied the denominators as opposed to kept the denominator. So what this question was all designed for is to make sure that you understand that when you multiply integers, you have to multiply the denominators, and when you add, fractions, not integers. When you multiply fractions, you have to multiply the denominators, and when you add fractions, you have to find a common denominator. Okay, you don't add them together. Question 4, well, we didn't say paper folding. Just a diagram how to do this. So this really, if you want to understand what this means, you have to be able to interpret it as being a quarter of 2/3. So once you interpret it being a quarter of 2/3, you can draw a rectangle, make 2/3 out of it. A quarter of that would be this much here. So once I analyze my picture, I used to have a fraction that was 3 as a denominator. Now my denominator is 12. And I have 1, 2, 3, oh, sorry, I don't. That's a lie. I have two parts out of 12, these two right here. Or in lowest terms, it would be 1/6. So your answer for the first one, 1/4 times 2/3 is 1/6. And if I use my algorithm, I'd have 1 times 2 over 4 times 3, which would give me this, which I'd then have to reduce down to lowest terms as 1/6. In the next one, start with a picture of a half. And I want to take 7/10. So for this one, actually, you know what? I'm going to make my rectangle a little bit different. I'm going to make my rectangle this way. A little bit smaller. So that's still a half. Okay, that's still half of the rectangle, but I'm going to take 7/10. So I'm going to cut it in half and then do 5 parts there. 5 parts there. There is now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 parts. Put check marks in 7 of them. 1, 2, 3, 4, 5, 6, 7. So my denominator used to be 2. Now it's 20. And the answer is 7 parts. This is 1 part. 2, 3, 4, 5, 6, 7. So I have 7 parts out of 20. So the answer is 7/20. If I use the algorithm, 7 times 1 over 10 times 2 is 7 over 20, and that's the same answer. An interesting way to think about this, whoa, there goes my thing again. An interesting way to think about it is you can also think of it as being percentages. So if you said, what is 70% of 50%, this fraction question really means the exact same thing here. So if you had 50% of something and you got to keep 70% of 50%, what would that be? So if I wanted to do this fraction question with a calculator, I could really say, well, 70% I know is this number. Of means multiplication, and this is 50%. So if I took a calculator and simply said, what is 70% of 50%, I would get 0.35. So my answer would be 0.35. Since this question and this question are identical, I could then say, well, this as a fraction is 35 over 100. It's 3,500ths, and in lowest terms, because both are divisible by 5, my answer would be 7/20ths, which is what I got up here anyway. Okay? So when you have multiplication of fractions, sometimes it's easier to think of it as being a percentage statement. All right, 70% of 50%. Then calculate that as a decimal statement, and then get your answer, and then bring it back to fractions. Optional. Question 5, it says estimate and calculate each product. So for this one, we said we didn't have to estimate. That's not going to be a part of this particular lesson. Just calculate each product using our algorithm. So 3/8 times 2/3. Multiply our numerators. Multiply our denominators. You get 6/24ths, which in lowest terms is 1/4, because both are divisible by 6. In the second question, multiply the numerators, multiply the denominators. I get 3/42. I know 42 is divisible by 3 because 4 plus 2 is 6, and 6 is divisible by 3. We know our divisibility rules, so I'm going to divide both by 3, and I get 1/14. That's my answer. And the last question, 3/4 times 3/4. 3 times 3 over 4 times 4 is 9/16. The last question, which is usually supposed to be the hardest, is actually the easiest because it is in lowest terms. 9/16 is your answer. Question 7 says Tamar had half an apple pie. So I'm going to draw a rectangle, and I'm going to let this represent the apple pie that Tamar has. She ate 1/4 of this piece of pie. Well, so she ate 1/4. So she divided that piece into quarters, and she had 1/4 of that piece of pie. What fraction of the whole pie did she eat? She ate 1/8 of the entire pie when she ate 1/4 of the half. Question 8 says Marius spends 1/3 of his time sleeping. So what I'm going to do is I'm going to make this a day. This is going to represent a day. Okay? And in that day, 1/3 of the time that Marius is awake, this represents sleeping. And I'll just put SLEEP for the right in there. That's all the sleeping time. But of all his sleeping time, 1/4 of that is spent dreaming about mathematics. So if I divide all of his day into this part into quarters, and say that that is 1/4 of the time he sleeps, or this part right here, that part right there represents his dreaming. This represents sleeping without dreaming. So his day was cut into thirds. Now it's cut into 12ths. So 1 part out of 12, that fraction of his day, 1/12 of a day. 1/12 of a day is spent dreaming. Well, how many hours is that? Well, a day is how many hours, Will? 24. So I'll put 24 there. So instead of saying 1/12 of a day, I can say 1/12 of 24. And if I put down 1/12 of 24, I can also put down 1/12 of 24. And when I do that, what I end up having is a multiplication of a fraction by a whole number. And in this case, if I have 1/12 and I multiply it by 24, how many 12ths would I have? The answer is I would have 24 12ths. But an interesting way, an easier way to think of this, as since we're tying it into multiplication of fractions by a fraction, most of us don't see the number 24 as being a fraction, but actually it is. I can think of it as being 1/12 multiplied by 24/1. That's the same thing as 24. And when I do that, I multiply my numerators and multiply my denominators, I still get the same thing as up here. And that's not in lowest terms. How many 12s are there in 24? There's 2. So therefore, of a day, in a 24-hour day, Marius would spend 2 hours of that day dreaming. Heck, I teach math for 2 hours a day, and 2 hours a day in my math class, most students are daydreaming, so I don't think that's quite accurate. Question 9 says 1/20th of people of the world live in Canada. or the US. So this rectangle is going to represent the world. The world. And I'm going to divide it into 24 equal parts. So I'm going to go 20 parts. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Nothing. So say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's the world, the entire world in a rectangle. And this little part right here is 1/20th. And that represents Canada and the US's population in the world. But it says of that 1/20th, of, which is our indication that it's going to be multiplication, of the people that live right here in this black shaded area, 1/10 of them are Canadian. So I'm going to cut this into 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9 lines. Well, that's way off in the middle there, but whatever. This one right here is 1/10 of 1/20th. And if you counted the number of squares in there, if they were half decently drawn well, you would find that only 1 out of 200, that is 1 square right there, that's Canada. This is all the US right here. 9/10 is the US, 1/10 is Canada. So 1 square out of 200 represents Canada in the population. Now what, that's as a fraction, so what percent's that? Does anyone know what percent that is? 1/200th? 0.5% is correct. So therefore, 0.5% of the world is Canadian. Or a better way to think of it, or an equally similar way, is 1/20th of the, or 1/200th of the world, excuse me, of the world is Canadian. Both are the same. Nope, because 1 out of 100 would be, if I was to go back there and change that 1/200. So if I take 1/200th and I want to make it as a fraction that represents a percent, what would I divide numerator and denominator by? I divide it by 2, right? Because that would give me 100 denominator, which is what the definition of a percent is. 1 divided by 2 is 0.5. Therefore, it's 0.5%. Does that make sense? Yeah. Question 10. At the age of 4, the average person is about 3/5 as tall as they will be as an adult. So right here, this is adult height. Okay. So at the age of 4, you are 3/5. So this right here, that's 3/5 of your adult height at age 4. This represents age 4. But when you're born, you're half as high as you're going to be when you're age 4. So if I take this and cut it in half, this represents your birth height. Okay? So therefore, you were 5ths, now you're 10ths. When you're born, you are 3/10 of your actual adult height. So right now, or 30%. So 3/10 is the answer, or 30%. So I am 187 centimeters long, tall, right? So if I'm 30% of 187 centimeters, or 30% of 187, or 30% of 187, if I take my calculator out and go decimal 3 times 187, since I'm an adult, I was 56.1 centimeters when I was born, approximately. If I take this ruler here, I was a tall baby. From tip to toe, I was this big right here. I was a big baby. That was a big baby. All right, question 11. Now, when we draw question 11, we're going to find that it's hard to draw it. So this rectangle is going to represent all of the medals Canada won. But 6/7 of all the medals we've won in both the Paralympic Games and the Summer Olympics, in both of them, of all the medals Canada won, 6/7, or 1, 2, 3, 5, 6 groups, 1/7, 2/7, 3/7, 4/7, 5/7. All those medals I just shaded in are all the medals that Canada won at the Paralympics. This would be Paralympics. This would be the regular Olympics. Okay? But of all the medals that were at the Paralympics, 7/18 of those medals, or just a little bit under half, of all these medals right here, just under half of them were gold. So in order to do this with a drawing, I have to make 18 lines this way, which is really tough. So instead of doing that, I'm going to rewrite it as a statement. So 7/18 of the 6/7 that were Paralympic medals are gold. So therefore, 7/18 times 6/7 would be your answer. Now, 7 times 6 over 18 times 7 is what we're going to use to get the answer, which is 42 out of 56 plus 126. Is that right? Okay. So 42 out of 126 is not lowest terms. What is the largest number that's divisible into both? Does anyone know? What is it? 42 is divisible into both. That is the largest factor. Now, if you didn't know that, what did you probably start with? 6 maybe, probably 2, right? So as opposed to me doing that to show you that Nathan's right, I'm going to reduce it by 2 first. It's going to get 21 over 63. Now, a lot of people would have said, hold on, it doesn't look like anything's going to divide into those, but 2 plus 1 is 3. 6 plus 3 is 9, so both nuns are divisible by a factor of 3. That gives me 7 over 21. And then some people might think that's lowest terms, but 21 is also divisible by 7. So you get 1/3. So therefore, 1/3 of all the medals that Canada won at both Olympics, 1/3 of all the medals that were won are gold medals from the Paralympics. Question 15. I hope I can do this right. Question 15, what are the missing fractions? So for the first one, it's fairly easy. 1 times 5 is 5. 2 times 8 is 16. So the missing fraction was 5/8. Now the next one gets tricky. Hopefully I can figure it out because I'm recording this. It'd be embarrassing if I couldn't. If I look at this one, I know I want my numerator to be 1. And I know that something times 3 can't be 1. So I know that this 1/3 must be lowest terms. So the first thing I'm going to realize is that the numerator, I'm going to guess 7. And if it's 7 there, and it's 9 here, I have no way how to explain how to do this rather than trial and error. But 7 times 3 over 9 times 7 equals 21 over 56. And since I haven't taught you cross reduction, I can't explain why I did that yet. But if you trust me, that's what it is. 21 over 56. Sorry, 63. I can't multiply. Both are divisible by 21, leaving you with 1 over 3. So the answer is 7/9. And the third one, it says 2/3 times what equals 1/2. So 2/3 of what is 1/2? Is what? What did you think it was, Carson? Not sure? What do you think? Does anyone know the answer? For number 3. Or C, sorry. What do you think, Chelsea? Three-fourths. Let's check to see if she's right. So what we'll do is we'll take this half, and I'll move it sideways over here, and I'll put an equal sign here, and I'll say, what does the product of 2/3 and 3/4 actually work out to be? Well, 2 times 3 is 6. And 3 times 4 is 12. And what's 6/12 in lowest terms? 1/2. She is correct. So the answer is 3/4. And the last one, 3/4 times what equals 5/8? 5/8. This is much tougher. Does anyone know what this is? What do you think the denominator is? Go ahead, Chelsea. Yes, it is 6. How about we all try and work? Hey, I'm going to press pause for a second. I want everyone to try it right now. Hang on. Okay, so we're back. So Chelsea, how did you figure it out? Can you explain how you figured it out? Before you tell me what the numerator is, how did you get it? So you realized that this was going to give you 24 as a product, and that you had to divide it by 3 to get your answer, correct? So whatever this number is here, this number divided by 3 must have given you 5, correct? Which meant that number in that small box must have been 15, which meant 3 times what is 15? 5, which makes your mystery fraction 5/6. Very well done. And finally, question 16 says, use the sum and the product of two fractions to identify the fractions. Question 16 is really a very difficult question, more of an enrichment question than anything. So, what two fractions do you add together to get 1/2? But multiply them together, those two same fractions, to get 1/4, to get 1/16. What do you think, Miss Betts? What do you think? Well, which one's the easiest one to figure out first, the multiplication one or the addition one? The addition one you think is first? What plus what is 1/2? Which one would you think? It's still yours. No, that's the easy one. Is 1/4 plus 1/4 1/2? So your first guess might be 1/4 plus 1/4 is 1/2. However, you could have also had a sixth plus 2/6. And when you add those together, what would you get? 1/2 as well. So there are infinite possibilities. So the answer to this is, it's easier not to think of the addition first, but it's easier to probably think about the multiplication first. So what is the multiplication statement? What do you think? What are some possibilities? It could be 1/2 times 1/8. Would that work? It could be that one. But is 1/2 plus 1/8 1/2? No. So that's one that works, but it's not the one. So then we try, what's another fraction times another fraction? What else would work? 1/2 times 1/8 works. What else? 1/4 times 1/4 would work. As we just figured out, 1/4 plus 1/4 is also 1/2. So the answer is, your two fractions for A are 1/4 and 1/4. Now for B, the sum, when it means I add them, I get 5/6. But when I multiply those same two fractions, I get 1/6. What do you think? Let's try our products first. What are the possibilities for the products? For product multiplication. There's only two. No, there's no. What are the possibilities for that? Anyone give me one of the, there's only one really I want you to give me. What do you think? Yes, 1/2 and 1/3. 1/2 plus 1/3 is going to multiply to give you 1/6, correct? Now let's double check what that is when you add them. So I'm going to put 1/2 and 1/3 here and see what happens when you add. So when I add fractions, I need what? Common denominator. What's the common denominator we're going to use here? 6 is going to be the common denominator. Multiply by 3, multiply by 3, I get 3/6 plus 2/6, which is 5/6. So the answer for that one is indeed 1/2, and 1/3. And the final one, sum is 2/3, so what fraction plus what fraction equals 2/3, and what fraction times what fraction equals 1/12. All right, what are our possibilities for multiplication? Which ones? 2/3. That's a weird one. All right, let's try it. Is it possible that 2/3 plus 1/8 is going to equal 2/3? No, so it's impossible. That's a silly answer. What's another one we could use? What's a more likely one? Yep. 1/3 times 1/3 would not be 1/12, it would be 1/9. 1/6 plus 1/6 or times 1/6 would be 1/36. The most likely possibility is this one. Would you agree? Okay, so let's look at this. So if I'm thinking of my product, it's going to give me 1/12. The two that I think of are going to be 1/6 plus 1/2 and 1/3 plus times 1/4. So not plus. Both of these are going to have a product of 1/12. Do you all agree? Right? And remember, my sum has to be 2/3. And 1/3 plus 1/4, I know for a fact without doing it, is not going to be 2/3. Why? Because 1/4, this has to be a third in order to add together to be 2/3. But if I look at the second one, this one right here, 1/6 plus 1/2, common denominator is 12. That will be 6/12 plus 2/12 is 8/12. Oh, heavens. Okay, we'll pick this up next time. It's actually 8/12, which reduces down to lowest terms as 2/3. So your answers are this fraction and this fraction.